So let's refresh our memories on what an empirical formula is. So remember, the empirical formula is the simplest whole number ratio of the atoms of elements in a compound. So it's that simplest whole number. So this is our simplest formula, is an empirical formula. So how can I find this? An empirical formula can be determined two ways. The first way it can be determined is that the masses of elements formed when I decompose or react my compound. And this is what's called combustion analysis. So in the real world, this is how we would find the empirical formula. Say I made something in the lab and I didn't know what it was. I kind of had an idea, but I wanted to figure out what the empirical formula was of this compound. I would do combustion analysis. So what combustion analysis is, I put it into a heater, to a furnace, it heats it up, it combusts it, it burns it, and then out comes the masses of the individual elements when my compound decomposed. So this would be what you would do like experimentally, okay? And you can actually calculate the math of all this. And if you take chemistry in college, you might cover combustion analysis. What we're gonna do, which is more of a theoretical side of it, instead of what you would do in a real lab setting, because this, it just spits out the empirical formula for you, is we're gonna find it using the percent composition. So we already talked about percent composition, so we're gonna use those percent compositions to do it. All right, so let's talk about how we're gonna do it. So we're gonna have a few steps to find the empirical formula. So the first step is we're gonna convert our percent to grams. So any of the percentages we're gonna convert to grams. And we're gonna do this by we're gonna assume 100 grams of my compound. Just like we did when we were using our percent compositions as conversions. Okay, we would change the percent to grams of that element and we would assume 100 grams of the compound. Step 2 is to convert the grams to moles. How do I go from grams to moles? I use the molar mass from the periodic table. So we're going to use the molar mass of each element. And you find that on the periodic table. Step 3. We're going to write a pseudo formula. It's not going to be our final formula. Pseudo means false or fake. So we're going to write a pseudo formula using the moles from step 2 as subscripts. Okay? Step 4 is that we're going to divide by the smallest number of moles. The big point here is to watch your rounding. We do not round until the very, very end. And when I mean like don't round, like leave a lot of decimal places when you're doing these steps. Don't round. If you round, your final answer is going to be wrong. This is one of those types of problems where if you round, I guarantee your answer is going to be wrong. You want to keep a lot of places because we need to have a lot of precision on this. All right, step 5, you may or may not have to do step 5. So step 5 just depends on what we get when we do step 4. You might have to do it or you might be done after step 4. So step 5 would be to multiply all mole ratios by a factor to make all whole numbers. So for example, if my number was 0.5, what would I need to multiply by to get a whole number? You would multiply by 2. If my number was 0.33 or 0.67, what would you multiply by? lastly, if it was 0.25 or 0.75, what would you multiply by? 4. Now, if the number is a lot lower than 0.25 or a lot higher than 0.75, at that point you could just round up or round down, okay? But if it's closer to 0.25 or 0.75 or in the middle, you have to do one of these rules, okay? So, on the next lecture, lecture that we're going to watch, we're going to talk about how to actually find the empirical formula. So, we'll do a practice problem.